Swayam Prabha. Digital India. Educated India.
So, welcome to lecture 3. In this lecture, we will try to see the product design morphologies. The content of this lecture is going to be problem confronting the designer, next the steps of the engineering design process, the third one is defining the problem and settling objectives, then developing provisional design, evaluation and decision making, and the morphology of design, the 7 phase. So, all these topics will be covered in this lecture. Problem confronting the designer. The product has certain properties. We said it has to be functionally good, it has to be quality, it has to be reliable, it has to be economical. The product has certain properties. Some of these properties are intrinsic, some are extrinsic and physical form of the product. So, these are some of the properties: intrinsic property, extrinsic property and physical form of the product. The challenge for a designer is to make products useful for customers and make change from function to form. So, function is one and form is the other. Okay. These two are different terminologies. So, the challenge for a designer is to make product useful for consumers and to change from function to form. It is always possible to make products having equal set of functions. Okay. The design methods can help, but imagination and creativity are important to transit from function to form. So, this skill is also very important for a product designer. So, a design method can help, but imagination and creativity are important to transmit from function to form. So, this is a very important statement. So, imagination and creativity are important to transit from function to form. Function is what are all the functions which a product is supposed to make. A form is what is the shape which has to be incorporated into the product. For example, we have majority of the phones flat, smartphones as flat. Why don't we have a cylindrical phone wherein which it is something like your pen which can be kept inside a pocket, which has a cylindrical circumference. Design thinking has 5 steps. One is called as the empathy study. Empathy study means you just go to the customer, ask the customer what problem he faces and you become the customer himself or herself and try to understand the problem from the customer point of view. So, it is learn about the audience for whom you are designing. So, first you go get into the shoes of a customer himself, understand what all problems he faces and then you come out and look from the designer's perspective how can you solve the problem. So, empathy study is very important. Empathy and sympathy are two different terms. A designer should have a empathetic feeling. So, he should get into the feelings of a customer, look at the problem and then note down all the problems what he faces and then start looking for solutions. Once you look at all the problems, you note down all the data, you note down all the information whatever, note down all the data. Then on this data you try to rearrange the data such that you get a proper information and then what you do is you define the problem exactly. For example, I was talking to you in the last lecture, I feel cold. So, that is a problem statement. You can't say that I need to buy a sweater. So, when you say I need to buy a sweater, you are almost finalizing that you do not need a jacket, and sweater is one solution towards solving the problem. But what is the customer facing? I feel cold, that is it. So, moment I say I need a sweater, then naturally your further processing of the problem goes around finding out alternative sweaters to keep you warm. But moment I say I am cold, I want to protect myself from cold. So, you can look at a jacket, you can look at a sweater, you can look at a shawl. So, all those other alternatives are there. Okay. So, moment you do that empathy study and then you get the information, now you clearly define the problem, what is that a customer wants. So, I feel cold, the customer needs something to protect himself. The next question comes is whether it has to be light or heavy. Then the next question comes is should it be only matching fitting to him, or he is also looking for his friend also. That means to say is he interested to go for a matching fit, a shirt, or is he looking for something like a shawl. So, now you see I have defined properly that I need something to protect. So, construct a point of view based on user needs and insights, you start defining the problem statement. Okay. The next one is ideation. In ideation, what we do is we try to develop several alternative ideas in trying to meet out the solve the problem. So, here what was the problem? I feel cold. He has to be protected from cold. The alternative solutions are sweater, jacket, shawl, whatever it is. So, these are ideations. So, brainstorming and coming up with creative solutions is nothing but ideation. The next one is you make prototype. See, as far as buying is concerned, the problem ends there. He chooses one and then he goes. But if you want to make a product, so next what you do is from this ideation, you start making prototypes. So, you try to whatever the customer wanted and whatever you have understood, whatever alternative ideas you have generated, with that you try to pick one idea, make a prototype and show it to the customer that is this idea or is this product happy for you. Do you feel satisfied with this solution for your problem? So, that is nothing but making prototype. So, build a representation of one or more of your ideas, show it to the customer. It can be one, it can be n. So, you show it and then ask the customer to pick, okay, this solution is much better. So, then what you do is you start working on engineering design problem solving, and then finally what you do is you start making it to the requirement and then you start doing testing. So, return to your original user group and test your ideas for feedback. Suppose here you made a prototype. Prototype can be in terms of functionality alone, it need not be in terms of form. So, after that what you do is moment you have understood all the things what he requires in a prototype, you take that idea and then put form also to it, make it as though it is final and show it back to the customer, get his feedback and start doing it. So, here this is the testing phase. So, this process is called as design thinking. You should do an empathy study and then you should define the problem, you should develop several ideas, then after that you will develop prototypes. Prototypes can be in terms of functionality alone, it need not be in terms of shape, size, form, it can be only in terms of functionality. Then from there you pick it and then you go. So, here it will be almost like your final product. Almost like your final product, you show it to him and then get it. So, what you develop after testing is also not the final product, you show alternatives and then you make it to a final state, and after this what you do is you start looking forward for design for manufacturing, design for and then productivity, manufacturing capability, all these things will be thought of after this. Before this, it is more towards accepting the idea, and here till here you do not work on economics. After this, you start working on optimization, then you start working on economics. So, steps involved in engineering design process, which we saw: problem definition, it is all about needs and surroundings. Then value system design, it deals with aim and range. System synthesis, to generate other options. System analysis, to evaluate other options, and then select the best system, evaluate alternative according to the predefined range, and then planning for action, it is about specifying the choice. So, these are the steps which are involved in engineering design process, which was put out by Hall in 1968. These steps can be seen in many design processes. Actually, the best method is to select best out of all alternatives. So, this is very important. So, whatever I said here, design thinking, it is almost the same which is on engineering design process. So, problem definition is the first step. Value system design, it is it deals with aim and ranges. Then system synthesis, to develop to generate various options, then to evaluate those options, then choose the best out of their options, then plan your actions for making the proper choice. These are the steps which are involved in doing it. So, first step 1 is identifying the need or the problem, research the need or the problem. So, this is just overlapping design thinking, engineering design process. All these things are just overlapping, which here is put in a much micromanagement step. So, research the need or problem, develop possible solutions, select the best possible solution, construct a prototype, test and evaluate, communicate the solution, and if there is a need, you redesign and then you keep continuing. So, design is a cyclic process. It keeps on and no product which comes to the market is the ultimate one. For example, if that is the case, then everybody in this universe should use only a same smartphone. But depending upon the choice of the customer and the application, there are several smartphones available. So, what I am trying to say is, in design there is nothing called a unique solution. At that point of time, to this customer might be a unique solution. So, there is alternative solutions for the same problem. So, that is what we are trying to say here. So, problems, whatever you understand. So, there is a possibility that you communicate, and then if there is a need base, you redesign and meet out to a new customer. If you go back and match this for your different stages of technology development with respect to time, we had 4 stages. So, whenever it comes to that matured stage, we will always try to reiterate, push it back, and then do redesigning and come back to this early stage and start doing it. So, these two are linked. So, these are the different steps which are involved in engineering design processes. So, the principal use of the solution to sub-function are basically scientific and engineering principles. So, it is not just like hearsay and you randomly do. So, it is more focused towards these two. So, the principles used for solution to sub-functions are basically scientific, and engineering principles will be there. So, scientific means Newton's law, Archimedes principle, whatever it is. So, all these principles are used, and then you try to go ahead with the solution of doing it. So, Paul and illustrated this illustration of solution is, first what they said, market, company, task is market, company, economy they say, and then they get into planning and clarifying the task. Then required list of, that is design specification they do. This is called as a planning and clarifying operation. Then what do? They try to develop conceptual design. So, develop the principal solution. Concepts, you have developed several solutions. So, you build up a concept. Then after that what you do is develop the construction structure. You do a preliminary layout, and then you define the construction structure, define layout, and then preparation, a production and operations document. So, this is what is detailed. This is detailed. So, here in which we do optimization and we try to come out with what is the machinery, machine to use, what is the tool to use, what is the layout of the factory, all those things, small things come out with the detailed design when you start doing it. Or if you try to take a product, then we talk about tolerances, we talk about finish, we talk about texture. So, all these things, detailed design of a particular product comes into, and then product documentation comes, and then you talk about solutions. Okay. So, this is what is it. So, you would according to Paul, so you will have a planning and clarifying, conceptual design, and then this is called as embodiment design, wherein which you try to give a shape to the product. So, till here it is concept. So, develop the construction structure, the preliminary layout, and then define the construction structure. So, it is giving shape to the complete project, whatever it is. So, before that what we did was we tried to do a conceptual, you look for solutions. Okay, let us just take another example. I want to make a machine which is used for egg omelette. Okay, omelette. So, here what I do is, so first step is step 1, I have to break an egg. Step 2, I have to add ingredients, whatever it is. Step 3, I have to mix the ingredients. Step 4 is I have to pour in a hot pan, hot plate. And 5 is I have to decide whether it has to be toasted both sides. And then 6, I have to remove it from the hot plate, remove. Okay. So, these are the steps involved. So, what was the problem statement? First, I have to identify how do I want to make a omelette making machine. So, that was a clear problem statement. Then what did I do? I did all the steps which are involved, I did. I have not gone in depth. So, I have just said put down all the steps. So, now for these steps I would try to develop a machine. So, in this machine what I will do is I will try to apply principal solutions. For example, should I use microwave, should I use induction heating, should I use a coil heater. So, all these things I try to put the concept. Once I do this concept, I put all these things and construct how it should it be in a cuboidal shape, should it be cylindrical, should it have several indexing stations, should it be only one station. So, all these things are construction, the shape, the size, the steps involved, all these things are construction structures we do. And finally, what we do is we define the layout, and after this we prepare the proper documentation, why did we do it, and then product documentation is done and the solution is given. So, these are the steps which are involved for one simple example which came to my mind. So, first you try to do it scientific, and then engineering principles are used. So, no product can come just out of the moon, out of the blue, it cannot come. There has to be some scientific backing, there has to be some engineering principles, and then only you can start developing a product which is worthy and which is functional and which has quality in it. So, defining the problem and setting the objective. A problem is the identification of the need that is unfulfilled. To formulate a problem, need must be clearly defined. What was my need? I need to make an automated omelette making machine. But before that, students, I did not address will this be economical or not. I wanted to make an automatic machine, true. I wrote down all the steps, true. I came out with a wonderful product, true. A very reliable product, true. But I did not work the economics of it. If I buy a machine worth of 25,000 rupees and the output is I can make for every 30 seconds one omelette. So, the consumption rate of omelette is 30 per day. My production cycle time is 30 seconds I can make one omelette, but my consumption, that means to say I will have only 30 customers a day. What is the point in developing or buying such machine? So, that is something which is very important. I did not explain to you and I did not put the economics to you. If that situation is there, then no point in developing a product. So, you just be happy appointing a person and he is multitasking fellow, he does this job, that job, you can optimize and get the job done. So, that is what I am trying to say. To formulate a problem, need must be clearly defined, and when you define, economics also should be one among them. What is the costing we can do? Is it truly justified that we should automate it? Okay. Initial steps is to clearly define the aim and also to elaborate it. First, you have to do all those things. You have to write it down, what is the aim, and be very elaborate. And when the need changes over from a vast goal to a specific goal, the objectives can change. So, first is okay. So, when you go back, I need to make an so why did I go for this omelette making machine? I thought that maybe it is a dirty process. Maybe it is a dirty process. I do not want a human to do it. I want a machine to do it. So, that is what was my goal. So, first thing, but now I realize, after putting all those things, I realize maybe I need to make a beating station, I need to make an induction station where these two are the dirty process. I want to just make them clean. So, when I had a vast goal, that was completely different. Now, I have a specific goal. So, what I have to do is look for only a very efficient heating technique, and then this heating technique should be also something like universal, so that other processes also can be used by the same heater. So, when the need changes, from the vast goal to a specific goal, the objective also changes. Whenever the change takes place, it must be clearly defined, or you are supposed to redefine your objective. Is that clear? So, you are supposed to redefine your objective. First, you have to clearly formulate a problem. Then, when you go detailed study more and more and more, now you try to see, okay, this entire thing is not required. I do only a partial of it as automation. That is fine. So, whenever the change takes place, the definition must be redefined clearly. The objective tree method is a good method to define a goal. Intention should be to clarify all the objectives and sub-objectives which is there in the problem. So, this is the objective tree method. What is your main objective? My main objective is, in the omelette example, is to make a clean kitchen maybe. Now, in this clean kitchen, I have several things to do. So, one of the objective is to make a machine for this egg omelette. Okay. And then what are the objectives? So, objectives are, it should occupy minimum shape, it should be energy efficient, it should have a control over ingredients flow or addition. So, these are some of the objectives. So, this is a tree method. So, you are always expected, the tree method will give you a good way to define your goal. So, now once the goals are defined, so now you start tackling each goal and start looking for solution for each goal. So, when you try to have solutions, these solutions will be clubbed and they try to give a sub objective. From the sub objective, you go to the main objective. Okay. So, this is a method which is used, which is called as objective tree method. It is also very important, and if you start following this, maybe in your day to day life also, if you start following the objective tree method, you will see that you define the problems very clearly, your objectives are set very clearly, and you start going towards your goal. So, many a times what happens in your day to day life, you try to give more importance to small events and you miss out your objective. But always try to keep the objective as a primary thing. For this objective, is this action going to help? If it is so, please do that action. If not, please drop that action and do other things such that you meet out the objective. If you try doing this in your day to day life also, you will see that things are becoming much more efficient. But every time what you are supposed to do is, you have to clearly define the problem. Okay, this is for life, this is for product designer, anywhere please use this. You have to very clearly define. If you do not clearly define, you will never be able to reach out to the solutions. The objective tree method, the problem can be scaling, non-scaling, or in the form of requirements. Okay. So, the problem can be scaling, the problem can be non-scaling, or in the form of requirements. Example, temperature cannot exceed 300 degrees Celsius. Okay, let me tell you interesting problem which I am currently working on. See, today there is a peculiar problem when the newborn baby comes into existence. We always see that when the temperature goes high, there are problems. So, doctor comes and attends to the problem, give medicine and tries to reduce the temperature. There is another problem, the temperature can go below the normal temperature, which is very alarming. So, when it goes below the normal temperature, today the state of the art is you have so many thermometers which measure normal and above. We do not have a temperature thermometer which measures normal and below. Okay. So, this is what I am trying to say. So, when you talk about scaling and non-scaling and all, so it is completely different. You have to look for new solutions, right. So, the problem is, what is that you have to look forward? It is normal and below the normal. Okay. So, then you start looking at, suppose if I say the objective is to give a solution for temperature, then if my sub objective is to, now only I say that okay, it is less than a normal temperature. Now, you see the objective itself is changing. The problem can be scaling, non-scaling, and in the form of requirements. So, this is one thing. The comprehensive list should be maintained and the checklist approach should be adopted for the objectives and the sub objectives. Whenever you try to develop a solution, you have to look at whether the sub objective is met. So, if the sub objective is met, whether I am meeting the main objective. So, this is the second thing, which there has to be a comprehensive list which is to be maintained. A list of 24 factors was given by Pugh in 1980 for the checklist format. Further, these factors were summarized by Rosenberg and L. So, they said performance, environment, life in service, maintenance, target product cost, transportation, packaging and quality. These are some of the factors which are to be considered while trying to define the problem and set the objectives. So, there are 24 factors was given by Pugh. But then this next gentleman, Rosenberg, what he did was he packaged all these things into 8: manufacturing facility, size, aesthetics, material, product lifespan, standard, ergonomics. Ergonomics is more towards comfort. This is a separate topic, we will read it in detail. So, it is more towards comfort of operation, I would say. Okay. So, should I keep the what should be the size, where should be the switch, all those things. Then quality and reliability, shelf life and storage, testing, safety, product policy, social and political implications, product liability, installation and operation, reuse, recycle and disposal. These are the factors and which was summarized by Rosenberg and Ickel, and these are the things which are to be considered while defining the problem and setting objectives. So, next thing is establishing function. So, in establishing function is setting requirements and developing specification is the next one. A functional analysis to know the exact demand of product must be done. After re-examination and editing the objectives and sub-objectives, this will be done. Setting your requirements. The designer must be aware of input and output of the products. Designer must be aware of functioning and the requirements of the products and components of the product. The component can be a person or a mechanical or electrical device. A functional analysis must be done to analyze achievements of the product. Some appropriate limits bounded on product is called as setting performance specification. For example, I try to make a sub assembly which gets into a full product. So, now in that sub assembly, the dimension, shape, size, weight is all the setting performance specification, are limits bounded on product. Okay. So, what it cannot be more than 100 grams, it cannot be more than this, it cannot be more than that, it cannot occupy more than 20 square 20 cross 10 millimeters, whatever it is. So, these are all the setting requirements and developing specification. First, problem identification, then after identification you have to fix your objectives, then in your objectives then you go to sub objectives. When you try to fix the sub objectives, you will all try to have a quantitative specification such that it helps a product designer to make the product easy. The performance specification should not be too narrow and it should not also be too broad. For example, so this is y and this is x. So, this can be time and this can be performance, whatever it is. So, if you say that I would like to develop a product in this zone, this is a very broad specification. If I say I would like to develop a product only in this zone, it is too narrow. Okay. So, then it is always better to neither be too broad nor be too narrow, try to be little generic such that you can try to cater to multiple customers. One way to generate performance specification is the method require use house of quality interaction matrix, which product attributes as rows and engineering characteristics as columns will be used to come out with performance specification. We will discuss house of quality in the forthcoming sections of this course. So, house of quality will be dealt in one of the lectures. So, do not worry about it. So, here basically what we talk about in house of quality is there will be rows and columns. So, we will try to see there will be rows, there will be columns. Okay. So, what we do is we try to do a mix and match and we try to give a ranking for it, and then we sum up, we get into some values and then we come up with the performance specification. A weight or a relative importance is assigned to each attribute. The value of the strength of the product can be got through multiplying weights and relationship scores. The target value of each parameter is set on the basics of its importance and competitor products. So, we will see more in details about house of quality later down the line. So, the next is developing professional design. So, when you talk about professional design, so here what we do is we look at association methods, creative confrontation methods, analytical methods are the main methods which are used in developing this design. So, this is important. Association method, creative confrontation method, analytical methods are main methods of design. So, I will stop here. Thank you.